All right. At the top of the hour here, we'll go ahead and get started. Thanks everyone for joining. My name is Alex Shattuck. I'm the new Director of Grid Transformation at ESIG. I've just started ESIG for about 2 weeks now, and before joining ESIG, I was a member of the engineering team at NERC, where I did IBR related efforts at NERC, and I spent quite a bit of time, I guess, throughout the industry doing consulting work and into interconnection and transmission planning. And I also spent some time with a wind manufacturer. So got quite a bit of a broad background that I'm hoping to bring to ESIG and kind of use that to execute ESIG's mission here with all of us moving forward. So ESIG serves as a leadership in a leadership role with the Global Power System Transmission Consortium. That's the G-PST. And the G-PST's mission is to bring together key actors across the globe to catalyze a rapid, clean energy transition at an unprecedented scale and speed. This is being done by providing a coordinated and holistic approach to necessary knowledge, education, and support to power system operators across all 5 of the action pillars. That's the G-PST's action pillars. At the core of the G-PST is a large cross-section of system operators from around the world who are dealing with a rapid transition from a system based on synchronous machines to one built around inverter-based resources. The 5 pillars of the consortium include 1, research and peer learning, 2, technical support, 3, workforce development, 4, standardization, and 5, open data and tools. ESIG is a co-lead on Pillar 1, and that's research and peer learning. That's along with Mark O'Malley of Imperial College. And for more information on the GPST, you can find that at their website, which is www.globalpst.org. Just global PST, no spaces or anything, just lowercase.org. I think we might have a link to that somewhere else for y'all to see. As a co-lead of Pillar 1, ESIG likes to welcome you all to this November webinar. And this is a joint GPST Pillar 1 and ESIG webinar series. This series is an addition to the regular ESIG monthly webinar series and focuses on the GPST research agenda and associated topics being addressed in Pillar 1. Topics are presented by both system operators as well as members of industry and research community. An additional series of webinars on the other 4 pillars of the GPST is also being provided on a monthly basis, and that's through NREL. For those of you who would like to learn more about the GPST and how to engage, again, you can go to our website. It's globalpst.org. You can click the Get Involved tab. And then further information on ESIG, you can visit us at www.esig.energy. Not .com, but .energy is the domain. Before we get started with our presentation today, a couple logistical items. First and foremost, we're going to have everyone muted for the duration of the webinar, just to avoid background noise. For the Q&A section, we're going to use Slido like we usually do, and that's slido.com. And then you'll enter ESIG12, ESIG12, and that's the event code. And then we'll be monitoring that throughout the webinar here, and we'll use those for the Q&A at the end after the presentation. When you look at that screen and you see the questions, you can thumb up or thumb down or vote for your questions or the questions that have been posed, and the thumbs ups get popped to the top of the list, and we'll likely take those questions based on votes and pass them on to Fred in the Q&A section. We're planning to save about 10-15 minutes at the end for Q&A, and then wrap up at the top of the hour, just to give us some time for question and answer. An email link will be provided once the video has been uploaded and posted to ESIG's website. And we also plan to provide short responses to unanswered questions after the webinar. So please, if you have a question, just ask it. Even if we're running out of time, you can ask it, and we'll take those questions and provide short responses to those questions that we didn't actually get to in the question and answer section of today's webinar. So with that, that's kind of the front matter here, and we'll get into our speakers, our speaker today. And first, we'll talk about the topic. So today's topic is an update on the grid forming inverter control technology adoption in ERCOT. There's a lot going on in Texas, and things are moving very quickly. As you can imagine, with the changing nature of the resource mix due to the retirement of conventional synchronous machines and their replacement with inverter-based resources, many aspects of system design and operation are going to be changing. We're all observing that every day. Operation and control of the new IBR, inverted race resources, is just one piece of this kind of changing landscape, but it's also a very important one as it deals with the stability of the system as a whole. And this topic is of increasing interest and critical importance to the industry as a whole, not just in ERCOT, but the rest of us as well. Today's webinar will provide an update on ERCOT's ongoing efforts, including potential reliability benefits, performance expectations, test frameworks, and progress on the adoption of advanced grid support for battery energy storage systems. And that's referred to in ERCOT's energy storage resources, or as ERCOT's energy storage resources. Our presenter today is Fred Huang, Director of Operations Support at ERCOT. Fred joined ERCOT in 2006, right after he received his PhD in electrical engineering from the University of Texas in Arlington. He's worked on both system planning and system operations, including work on his renewable integration, system stability and security, interconnection requirements, and transmission planning, among others. Over the years, really greatly value Fred's work and really appreciate all the work he's doing in providing technical support and leadership to the industry. He's a good friend to ESIG, and we look forward to hearing what he has to say today. And again, just before we get started, quick reminder again to please use Slido for the questions and answers. Again, that's slido.com. And the event code is ESIG12, ESIG 12. And let's please use that to ask your questions, and then also vote yes or no for questions you really want to see answered. And that's it. That's enough of me. So let's go ahead and get started. Fred, it's your webinar. Please go ahead.
Thank you. Hello, everyone. Just want to make sure, just do an audio check. Is okay?
Yep, you sound great, and your video looks good.
Great. And first of all, I think thanks for the very kind introduction, and have opportunity. We can provide a kind of status update related to the grid forming technology adoption in ERCOT. Then I think without further ado, we can just go ahead to kind of go to the content. So I think today, we'd like to take the opportunity to kind of have a quick update in terms of what's the current ERCOT status focused on the inverter-based resource. And also kind of take back to see in the last kind of 10 to 20 years, what's the evolution about the ERCOT inverter-based resource integrations, and along with our performance expectation and the requirements. And as Alex mentioned it, the system has been changing quite a bit with the domination of inverter-based resource, at least under certain conditions. We do see the system characteristics, basically the voltage and the frequency has been changing quite a bit. So that really triggers us to go into the options, how we can continue to maintain the desired stability and the reliability for the grid. So we definitely look into, so we'll kind of share some options we have considered and implemented, and also kind of share what kind of the driver to help us look into the grid forming technologies as well. Then lastly, definitely try to provide a current status update and our next steps. So this is kind of a quick, good one-page summary about our current status in ERCOT in terms of inverter-based resource integrations. So our peak demand is 85.5 gigawatt. It was recorded in summer 2023. As a fact, this year, we get very close to this number as well, but not yet exceeded. In terms of inverter-based resource, I'll say as of June this year, 2024, we have total of 39.5 gigawatt wind installed capacity connected to the ERCOT transmission grid. And for the solar, we have exceeded 25 gigawatt also connected to ERCOT transmission grid. On the energy storage or ESR, the battery side, we have 7.7 gigawatt as well. So all of them, the number here, they are all connected to the transmission grid. This does not include the distribution as well. But you combine this one, is already big amount of the inverter-based resource already connected to the ERCOT grid. In addition, we do see the continued growth in the future as well. So in terms of the penetration, I think given the capacity installed to ERCOT is not a surprise. We could have very large penetration or output from renewable, including wind and solar. So I would say combined together, the highest penetration from wind and the solar to serve the ERCOT load at the moment was 75%. It was recorded early this year in March. So that's really kind of a highlight to show how our system has been involved and how the system characteristics will be changed along with inverter-based resource integrations. The bottom two charts show a kind of very typical number in terms of 2024 generation capacity perspective. You look at the wind and the solar together with the energy storage already, we have more than 40% capacity provided by inverter-based resource. From the energy production, energy use perspective in 2023, we have close to 30% the energy was produced by inverter-based resource, particularly wind and the solar. So kind of after a kind of quick overview, so these slides try to kind of show, is a kind of busy slide, but try to kind of convey several key messages. Is the chart in the middle is really the integration history in the last 10 years. As you can see, we kind of, in ERCOT region, we started with a wind generation back to early 20. And then in early 2020, we start to see the solar integration, kind of very rapid growth. And soon after, the energy storage kind of kick in as well, kind of pair with the solar together with very high and significant growth in the last few years. So per the number, I would say by 2025, we do expect solar will become the largest category of inverter-based resource in ERCOT. And by 2026 or sooner, depending on how actual implementation of the inverter-based resource connect to our system, we could exceed 100 gigawatt transmission connected inverter-based resource. So with all this amount of resource connected to ERCOT, not only they produce energy, I think what we need is also make sure how we can reliably integrate these inverter-based resources, allow them to have a continuous reliable output, but also provide a support to the grid as well. So the chart above is kind of a high-level overview about over the last several years. What's the kind of evolution about ERCOT, I would say, inverter-based performance requirement when they connect to our system. So when the capacity is not a kind of marginal, so we have a very minimal requirements as kind of similar to many other regions. Once you start to get more and more renewables or inverter-based resource connected to the grid, I think the impact to maintain the voltage frequency become critical. That's where we introduced the requirement for the voltage frequency control in 2008. We do have a requirement before 2008, but I think in 2008 we have more specific requirement and its performance expectation for inverter-based resource for the voltage and the frequency. Then also in early 2000, when we started to have a 4,000-5,000 megawatt inverter-based resource, through several events, we realized when there is a transmission typical disturbance, inverter could not write through, and that could cause the frequency issues as well. So we start to introduce and require the write-through requirement for inverter-based resource back to 2006. And along with the technology advancement, improvement, and the system grid needs, we do have several revisions on the write-through capability in 2014, 16, and the most recent one is 2024. Essentially, the latest one, you try to align with the IEEE 2800 standard. So moving forward, we do continue kind of revisit all the 2800 requirements and identify all the applicable one and work with our stakeholders how we can continue improve inverter-based resource capability and their support to the grid. And the most recent one is kind of today's focus as well is at the same time, we start looking into the grid forming as well. So these slides kind of highlight, kind of summarize selected, I would say, major concerns we have along with the inverter-based resource connected to the ERCOT in the last few years. We do have options, we do have mitigation, try to maintain the system reliability, but these are the one kind of typical and the selected one. We know we need to deal with it along the last several years. So all the existing inverter-based resource connected to ERCOT transmission grid right now, we kind of consider they are called grid following inverter-based resource, which they generally require sufficient system strength to reliably connect to. And at the same time, they also generally do not provide a system strength and also inertia like the synchronous generators. So as a result, the transmission grid could become more volatile and in terms of frequency and the voltage as well. So that really triggers us to identify the stability and the reliability needs. So the table here really kind of highlight for a grid when we have a reduced synchronous machine online and pair with kind of large growth or high penetration of inverter-based resource, assuming they are grid following together. I think the three major ones we encounter in ERCOT in the last several years is we do see increasing stability constraints, not only in the planning horizon, we also identify the need to enforce these stability constraints in real time. And that really, those constraints reduce the power transfer and depending on the condition, it could require curtailment just in order to maintain the stability. Similarly, because the system becomes more sensitive and more volatile, so for the disturbance with more sensitive frequency and voltage behavior, we do see the risk increasing unit unstable operations or even the trip. So that can cause some reliability and stability concerns. And the last one is not necessarily the actual performance, but really the confidence about the simulation and our models. With a huge amount of inverter-based resource power electronic device combined into the studies, I think we see increasing numerical issues. We also see some potential instability may not be properly identified or captured through our typical tool and the models. There are ways to improve it, there are ways to enhance it, but I think this is just to share with the group. So kind of narrow down to one kind of interesting area in ERCOT is West Texas. So in West Texas is the area where a majority of inverter-based resource they connect to and expect to continue to have a rapid growth, including wind, solar, and energy storage. And also in West Texas, we do have relatively limited few synchronous generation in that area. So combined together, it kind of very typical textbook, like a weak grid condition as well. So based on this condition, we do observe in real-time operations, and also several people on the call, you may be familiar with so-called ERCOT Odessa 2021-2022 event. That's kind of really highlighted in real-time actual performance to show the challenge for the inverter-based resource connected to the weaker grid. So system strength issues are an emerging ERCOT grid issues, and we try to identify solution to mitigate it. So over the last few years, I would say we do try to identify all the options we can to improve the grid, maintain the desired stability and the reliability. So, but we do see potential continued growth of the inverter-based resource even go beyond what we have today. So let's also help us to look into further about any other different options and the best practice in the industry. So the options we have been thinking about it, and we get a very good our ERCOT stakeholder support and input. So these are the selected, I would say, notable one to share with the group. So the first one is the synchronous condensers. So back to 2018, we have the first two synchronous condensers, each with 150 MVA. They were installed in West Texas, and really try to provide system strength and voltage support for the reliable operation of inverter-based resource. I think with continuous growth of inverter-based resource in the region, so last year we got supported to have additional 6 synchronous condensers, each with 350 MVA. They are scheduled to be implemented by 2027. The other options from the inverter-based resource capability perspective, as the group may be very familiar with the IEEE 2800. We also think this is a very good reference and a kind of is guideline for us to work with our stakeholders and the OEM to see how we can have a better performance by the inverter-based resource to provide a great support and stability. So this year, we adopted a voltage and frequency right through, and also the section 579 in IEEE 2800. And we do plan to continue to adopt the other applicable requirements in the future to work with our stakeholders as well. We do recognize the challenge on the models and the tools. So in the last few years, we established the requirements, try to have a way ensure accurate dynamic models and the behavior as well. And we definitely closely monitor, try to participate IEEE 2800.2 as well. Once it got finalized, we plan to also adopt the applicable requirement in the future. The last one, not a really enhancement, but it's really the tool we have in ERCOT, just try to ensure the reliable real-time operations. As I kind of mentioned earlier, we do see the increasing stability constraints. So we have established and enforced operation stability constraints in real-time operations and try to better assess the system condition in real time. We also implement online stability assessment, including voltage and the transient stabilities. So kind of continuously, we are going to look at all the options and consider the system involvement and all the options we have been tested, recommended, implemented. I think our observation and our viewpoint is for the grid support, really the continuous focus on improving not only the inverter-based resource itself, but also the transmission improvement option together. It will provide the most effective reliability improvement to the grid and the support. If we only rely on one or very limited improved options, we do see the kind of diminish the reliability benefit return as well. So that's really kind of have ERCOT to look into any other options. And in the last few years, among many other system operators, especially Australia and Europe and other regions, including Hawaii, they have advanced very well on the grid forming technologies. We try to learn from them to understand the best practice. That's how we start to look into the grid forming inverter-based resource in 2024. So I think this one just a kind of very high-level summary about our process in the last 12 months, how ERCOT start to engage industry, consultant, vendor, and our stakeholders to identify and develop our grid forming requirement. At this stage, it's still proposal, but it's a good journey. I think it is a good opportunity to share with the group. So when we start to think about, okay, we should look into the grid forming and what kind of benefits, what kind of consideration we should have when we try to adopt this one in ERCOT region. It's very typical strategic planning process. So we first start with the inputs. So we definitely reach out to many industrial expertise and regions, including NERC, G-PST, ESIG, which ESIG has a very good summary on their website about all the grid forming status update. I highly recommend everyone, if we are interested, you go to ESIG website and that will give you a very good overview. And we also reach out to the national lab, like the Pacific Northwest National Lab. And we definitely also reach out to the APRI and the Unify and IEEE. And by looking many other industrial reports and their hotter topics, that's really help us to get a very good kind of overview about the pro and the cons and kind of save a lot of time. Once we get at the stage, then I think our next stage is really to get into the engagement. So in this process, we do contract industrial consultant electronics to help us make a recommendation, given their expertise and their involvement in other regions already. And at the same time, we reach out to the OEM for the wind, solar, and energy storage together, try to have a good understanding about their status, their implementation, and their feedback on the grid forming implementation. And definitely, we reach out to other utilities and system operators to learn from their experience as well. So once we get into that stage, then in analysis, we get models shared by the OEMs. We get a lot of input from the national lab and EPRI, and our, I would say, consultant expertise kind of work together, try to identify what are the performance and the test framework we should consider for the grid forming technologies. And at the same time, we also try to identify if we do have this grid forming technology in ERCOT case or ERCOT system, what kind of benefit we can demonstrate it the grid forming can provide to ERCOT's reliability and stability needs. And if any concerns, we should be careful moving forward once we adopt it. So in terms of status right now today, I think we have communicated our findings, our observation to our stakeholders, and we try to share with the industry like today. And we have proposed our performance requirement and the framework. We also propose our adoption in terms of how we expect to adopt grid forming technology in ERCOT footprint moving forward. So it's kind of really the status of now. So along this kind of journey, I think I want to share several key observations with the group. The first one, I think, as I mentioned earlier, it's tremendous work by the industry right now. We do see very good, excellent industrial collaborations among system operators, OEMs, and developers. Their support are really the key to make us what we are today. Along this one, to be more specific, in this exercise and activity, we did engage 4 specific major energy storage OEMs. They share their detailed EMT PSK models with us, and to help us develop our performance test framework and expectation on the criteria. And the other one I want to share with the group is compared to many other regions in terms of their grid forming adoptions, I think the observation is the performance requirements generally are consistent among several system operators. I think that's a good direction in terms of like eventually it may kind of unify into a good, I would say, standardized requirement or expectation for the industry to move forward. And also compared to wind, solar, and energy storage, I think ESR energy storage today, they are available and considered ready to adopt grid forming. When the solar and the wind, they may still need some further investigation and development to be grid forming capable. So also the grid forming depend on your expectation and performance. They can actually be achieved with very minimal impact to the both hardware design as well as the commercial operations. So this kind of really a good kind of observation we see among the industry. On an ERCOT specific one, based on our assessment, if we do have grid forming to ERCOT footprint, based on the study, we do see the system stability, they can be effectively improved. We also see the system stability constraints I mentioned earlier can be reduced or even be eliminated. And definitely it will minimize the even impact as well. So we really see a good benefit to have a grid forming as one of the good options to improve the system stability and reliability as a kind of one of the toolkits we should consider. So our proposal for the grid-forming, I would say, just want to make sure it is clear at this moment. It is still a proposal. It's a proposal we have submitted through ERCOT formal stakeholder revision request review. So this is currently undergoing a stakeholder review, and the final will subject to the regulatory approval as well. So it may have some change based on our initial proposal, but I think the slides here kind of summarize our initial proposal at this moment. So for the grid-forming adoption in ERCOT, for now, I think we try apply to energy storage only. As I mentioned, the wind and the solar, they may still need more time to look into the potential barrier or potential need to provide a grid-forming. And the proposal right now is voluntary for the existing ESRs and expect to be mandatory for the new ESRs. And also, there are different regions needed based on the energy storage provider grid-forming support. In our proposal, we do not require additional hardware, also do not require to maintain a headroom all the time. So our proposal expect to have minimal impact to the project physical design, also have minimal impact to the commercial operations. And there's no requirement in our proposal to have a grid-forming battery provider break starter capability at this moment. We do expect the grid-forming ESR, they will be capable to meet all our existing inverter-based resource performance requirements, such as frequency support, voltage support, and the write-through requirements. In addition, they do need to perform additional grid-forming related specific tests and associated criteria to meet our grid-forming requirements. So at this moment, how we going to examine and make sure, check the grid-forming is performance and expectation, we expect to go through the models and definitely the future actual performance and actual operation experience. So the test framework, we kind of use electronics initially recommended one as our guideline to develop our proposal is how are we going to have a model requirement, how the test should be conducted, and how the criteria will be checked. In addition, all the inverter-based resource connect to ERCOT transmission grid, they are required to install the PMU and the digital fault recorders. And those requirements will help us moving forward, especially once in operation, to examine their actual performance and then may help to do the model validation in the future. So these slides kind of provide a very high-level overview is how we plan to use the models to examine and check the grid-forming capability per our proposed requirements. So as I mentioned it, if you are familiar with other system operators' grid-forming requirements, they may have some slight deviation, but in principle, I think we are consistent most of the time. So we kind of propose have a 7 test, and the first test is a flex start test, and the way we expectation for the grid-forming, I would say model testing and the performance requirement, they need to be done in PSCAD, they need to be done in the PSCE, they also need to be done in the TSET. This really helps us to make sure for the same test, for the same equipment under different model and the different software platform, we still get a very consistent response. So the second one is a phase angle jump. Because it's a unique phase angle jump, in this case, we only require PSCAD. But for the rest of the voltage related one as item 3, item 4, we do have a frequency and we call it inertia response as well. So the grid-forming by its nature, I would say control design, they will be capable to inject the energy to the system very quickly. And so we use the term as inertia is really try to mimic the impact to the frequency, especially the rate of change of frequency during the generation trip. So it's not the same inertia term in terms of synchronous machine. So we may actually revise this term depend on the final approval of language. But for now, this is a kind of placeholder just to highlight it in our grid forming testing. We are going to evaluate the energy injection in the initial transient period to see the impact to the frequency. Similarly, we also have a system strength test requirement. In our proposal, we do expect grid forming ESR will be capable to remain stable operation at a very weak system condition. In this case, we define the short circuit ratio should be at least lower to 1.2. The project still need to remain stable and reliable. Then we all have a typical, the large voltage disturbance is equivalent to the write-through test. And the last one is the loss of a synchronous resource test. It is not meant to require the inverter-based resource grid forming capability to be independent, operated by itself. But this is a good test. We can verify a lot of grid forming unique characteristics that is different from the typical grid following. So we do have this test required in a model test, but I say just try to codify. It's not our expectation or requirement to have grid forming kind of operated by itself in an island condition. So all these tests, together with all the models shared by the OEM for the energy storage, we examine one by one, just try to make sure not only we have good understanding about the performance out of each models, also our proposed requirement is reasonable and feasible to be accomplished by the existing, I would say, capability by the vendors. We do have several additional tests, like a series compensation test, impedance scan test, that could be required by other regions, but we have not adopted at this point. We plan to continue assess this test. We believe they are helpful and very useful. Just because they are relatively new, we think we need more time to look into it before we can work with our stakeholders to make us a requirement or ask them to help to do this test as well. Lastly, I think to facilitate the whole process, all the requirement here expect to be done by the developers and the resource entities or the owners. So we also plan, and we already developed the tools, try to kind of facilitate the industry to get this kind of model quality performance test be more timely and effectively. So we plan to develop our tools, and that expect to be, once it's ready, we expect to share with the industry as well. So the previous one kind of focused on the models. So we do have additional, we call it the model validation requirement as well. This type of test at a high level is our requirement is try to have the inverters through some hardware actual physical test against the PSK model as an example. Just try to make sure the models include all the details that can accurately represent the actual performance of the inverters. So I don't really go through the details of this test, but again, the high level is the previous one, we want to make sure the model is good and adequate. Here, we want to make sure the model included sufficient detailed components to represent actual hardware. So combined with these two, we think we can maintain a good quality of the models and accuracy as well. So this should be my last slide. So our current status is, as I mentioned earlier, we have submitted and we proposed this requirement to our ERCOT stakeholder and the revision request process. And I put a link on the slides. If you are interested, click the link, you will see our proposal in details. And again, it's still in the revision process. So the final requirement will be subject to the stakeholders' input and the regulatory approval. So after this one, I think our next steps, we plan to continue, consider not only the grid forming to inverter-based resource itself, we also will consider the grid forming application in the transmission improvement, such as the FEC device. And we do plan to continue collaborate with industry and other system operators to identify what are the best practice for our grid stability improvements. And we also will continue to investigate the potential feasibility of grid forming to other inverter-based resources such as wind and solar. And then lastly, we also will look into the potential application for grid forming to provide a break start capability. I think this kind of what I kind of provide a summary today. This is a list of the link of a reference. Hopefully that's useful for the team and the group. And I'll be happy to share any comments or to take any questions. Thank you for your time today.
Thanks, Fred. You're perfectly on time, just about, so, which is good, because there's a number of questions in the Q&A on Slido. And again, if you didn't get a chance to put your question in there and you have a question to ask, please go to slido.com, and it's ESIG 12, ESIG 12. So I can just go ahead and get us going here. So Fred, this is the highest voted question, but and I think you touched on it just briefly on a couple of your slides, but what challenges are you seeing regarding IBR modeling when you talk about grid forming and grid following in the same network? And have you noticed any interactions or other modeling or stability related challenges?
Yeah, I think I would say on top of my head, I can share kind of probably 2 to 3 points. And I know Alex and there are many experts on the call today. So I think for just use the case with a lot of grid following inverter-based resource models in our case, what we have been observed in the last few years is once you have all the grid following inverter-based resource connect to your typical, I call it positive sequence dynamic simulations, I think we start to see increasing numerical issues because a lot of power electronic control block require very short time constant. And also combined with all the existing the model and the tool, how it was written and prepared, we do see increasing stability, increasing numerical issues. The other challenge we see is in real time, we do see some oscillatory response or unstable response out of inverter-based resource under some special system conditions. So when we try to benchmark those in offline analysis, what we found is the tools and especially the models depend on the oscillation frequency. Some of them at weak grid condition could be 5 to 10 hertz, even higher. So depending on the tool you use, depending on the model you use, that may not be the right model and the tool to identify those phenomena. So that's another one we kind of see the challenges as well. So the last one is kind of industry, a lot of discussion about user-defined model versus generic model. I think in ERCOT, we do not have a requirement say you must use user-defined or you must use the generic model. I think what we require is as long as the model you think is accurate and adequate, we would like to have it. So what we see is if we have a lot and more grid following, the study become more complicated, become more challenging. And there are some system operator go into the PSK or EMT horizon. That's another complexity. If we do need to go to another route, what's the impact to the operation, timely real-time support? That's another one we need to think about it. So these are the few points I can think of. But I would say to share with the group, when we start to plug in the grid forming inverter-based resource to the study, we do see the improvement in the numericals instability. We do see the improvement on kind of the tools is more stable, and we kind of see the result become more reasonable. It still will have its limitation on whether you still can identify high frequency oscillation or not, but at least there are some more benefit once we have grid forming in the case. Thank you.
Thanks, Fred. Moving on to our next one here. First, the question is about the synchronous condensers and if they're in remote areas, I guess, respect to the load pockets. And then in addition to that, any new stability concerns that you've noticed from those synchronous condensers, or I guess any other challenges from those items or devices?
Yeah, I think this is a very good one. I would say I can share. I would say, when we have the first two synchronous condenser connect to ERCOT in the beginning, I think we definitely, like everyone, we conduct a very comprehensive analysis, but it was good. But along with more inverter connect to the area, again, we start to see oscillator response. That synchronous condenser, one of the options we look into in the past is, should synchronous condenser be capable provide I would say PSS function, power system stabilizer function like a synchronous machine. I think there are a lot of industrial discussion on this one, but due to the limited of megawatt support in synchronous condenser, it may not be very effective. And also need to be careful if you have a condenser at some condition, if it could be radial or become very weak, that's another one need to be how you determine the location. So as a lesson learned for our 6 condenser we recently recommended, we actually, one of the consideration is we want to place those condensers in a very meshed connected network, such that it will minimize the potential exposure to be very weak or to be very radial connected, that tended to have some instability challenges associated with synchronous condensers.
Thanks, Fred. We'll just roll on. 2 in a row, I guess, 2 related questions. So the first one is ERCOT NOGR 2.14. That requires GFM on all ESR in 2025. And the question is, do you think that this blanket requirement may slow down the integration of these energy storage resources, or could that have any cost implications? Or I guess, what are your thoughts on that requirement being a blanket requirement and the impacts of that?
I can expect the commenter is probably ERCOT market participants, because he can particularly code our node operating guide sections. I do expect we will have this discussion in our stakeholder process. As I mentioned, it is still in the revision request process. We will start to get stakeholders' input. But I think here, I probably just try to put a little bit details on this one, is the requirement for ESI in 2025 is not in service date in 2025. The requirement as a proposal right now is, if a project, you have a SGIA, if you sign the interconnection agreement after April 1st, 2025, then you will be required. And in general, when you are at a stage, it's kind of considered a very early stage of the, before you sign the interconnection agreement, it's kind of early stage of the projects. So the current proposal, again, is still a proposal, is all the project already signed SGIA today, they are not required to have grid forming requirement. Although we do encourage them to consider if they have a chance, because we do see the benefit not only to the grid, we also see the benefit to the stability and also inverter base itself for the stability constraints.
Thanks, Fred. And I guess the voting moved everything around on me. Let me see when I was going to follow up with. Okay, so in addition to that GFM requirement on all ESRs, what about fast frequency support or other voltage controls or other kind of advanced IBR controls on grid following devices? Have you considered those instead of, is what the question says, or maybe in addition to requiring the GFM for all ESRs?
So today we do have, we call it fast frequency support as part of ERCOT ancillary service. And maybe that's the term we need to kind of codify. I think for the grid forming, I think they are required to provide a frequency support just like the grid following we have today. I think the unique for grid forming is during the transient period, their capability to inject energy to provide a similar like inertia like support. That's really the benefit where the grid forming can do outside the grid following capability. And another one, as we understand it, is really the transient part. It should have a very minimal impact to your commercial operation and your design as well. And again, our proposal right now is you should not be required to have extra hardware design compared to what you are required today. and you should provide grid forming when you can, when you are capable. That's kind of our expectation.
Thanks, Fred. Let me give a quick second to see if anything else is just following on to these questions, but they're all moving around quickly, so I'm just going to keep reading off the line. So have you collected any data on the magnitude of additional costs or to provide short-term over current capability? And are there any kind of costs associated with that? That might not be something you can answer easily, but that's,
Yeah, and
short-term over current.
Yeah, and I think this is a good point. Like I try to kind of mention several times already is our proposal is, again, we are aware of other system operation requirements. So we try to kind of propose in a way the grid forming requirement for our proposal is not going to have you to purposely procure the project with extra overload capability if you are not required today. But we are aware of there are very good OEMs. Their product already by default come with some short-term overcurrent capability. I think if we are able to utilize it again, that would be great. But I would say it's not going to be required at this moment.
Thanks, Fred. Maybe we'll take a break for an easy one. Are these grid forming inverters available in the market right now? In addition to that, what about IEEE 2800? Is that available for market participants as well?
So I will try to answer the first one. The grid forming inverter, as I know, and Alex, I know you are experts on this one already as well, is there are physical installation for the grid forming energy storage around the multiple areas, including Australia and many other regions. And ESIG did a very good maintenance and update on this one. So you probably, I would say right now, it definitely is a handful of projects. They are either already in operations or they will be in the next few months or next year. So people are, if you are interested, go to the ESIG. They provide a very good and it's very timely update, as I know. That's a very good reference. For IEEE, I think I'll probably just say for ERCOT status right now is we do not do wholesale adoption for IEEE 2800. We try to go for kind of prioritize the requirements and the sections we feel there's a need that we go for first. So as of now, we do adopt the right through and section 579. And for those, we think the grid forming should be capable. We are aware of some pretty unique, I would say, response time issues between grid forming and grid following. But we think our language and proposal should provide enough flexibility to address those concerns.
Thank you. Yeah, on the 2800 piece, this was a topic at one of the more recent I2X workshops, the one that followed on the ESIG's fall technical workshop in Providence. And once those slides and presentations get posted, there's a lot of information on kind of current adoption efforts of IEEE 2800 across North America. So that's a good place to go read a lot of the details because, like Fred mentioned, different folks are doing it different ways in different amounts. So there's a lot of variability. So that's a good place to go look for specifics there. So next question here. The model quality tests from the dynamic working group don't have a specific performance requirements. That's settling time, rise times, voltage droops, dead bands, etc. I guess the question is, can those be added for GFM? But maybe they meant to ask, do you plan on adding anything like that in
Yes.
for GFM?
Yeah, the short answer is yes. And I would say we in one of our link in my reference slides, that is the test framework recommended by electronics, and we plan to adopt it. So I think at the end of the product, once it got approved, all the test framework, as I show in the slides here, and the associated performance requirements, they will be described, included in the ERCOT Dynamic Working Group procedural manuals.
Thank you, Fred. All right, gonna just keep rolling down the list. So if real-time stability, that's TSAT, correct?
Yes.
Okay, and then offline is PSSC. How do you, or have you noticed any issues with syncing up the data sets, or any kind of lessons learned for the difficulty of matching those data sets and making sure that both models are doing the same thing?
Yeah, thank you. Yeah, it was quite a bit effort. I think at a very high level, it took us at least 3 to 4 years to get a T-set model in a way is consistent with PSSE models. And again, I would like to take opportunity here to kudos to our stakeholders, our developers, and our OEMs. I say it definitely is extra work, but it's a benefit we can provide to the grid and to I would say system. And I would say it was a lengthy process, but I think we finally make it. So early engagement with OEM and the developer always the key.
Thanks, Freddie. I was part of that from the other side when y'all were doing that model update, and it was certainly interesting work and definitely beneficial. But it was sometimes it was difficult. That's for sure.
Yeah.
So the next one's kind of a hard question. But how much or what percentage of the grid following has been kind of converted into grid forming in ERCOT at this time? And the second part is, what's the target percentage of those types of conversions for the near future to meet the new requirements?
So as I am aware of, today, 0%. All the inverter resource connect to ERCOT consider grid following. And that's kind of the reason why we trigger this effort to see how we can work with our stakeholders to encourage and adopt the grid forming. So as of now, it's 0%. What we have done is we use real ERCOT case, and we kind of replace the real model with a potential grid following model to see what's the potential benefit and the impact. That's what we have done. In terms of percentage, I think we consider it, but I think our view is because at least right now, it applies to grid forming energy storage only. So from a penetration perspective, even you have a lot of battery with grid forming in our system case, consider wind and solar capacity we have, the penetration will not be that high. And I understand there are a lot of discussion about potential concern for high penetration of grid forming. I don't think that our proposal will really reach to that point.
Yeah, thanks, Fred. That's the $1 million impossible question we always get when we talk grid farming: is how much do we need and when? So we got about 1 minute left, so I'll give you an easy one to close us off before we wrap it up. But does ERCOT have any plans to move to requiring GFM on other resources that aren't energy storage?
I think at least kind of like I mentioned in our future next steps, I would say in this kind of effort in the last 12 months, we did engage with the wind and the solar OEMs. Again, their status may change and move very quickly today. But when we engage them at that stage, our takeaway is it's possible, it's potentially feasible, but it requires more time to think about it. So our plan is after we kind of finish or have a good step of about grid forming and storage, we do plan to continue to kind of work with industries, especially OEM, about the wind and the solar. So for now, at least on our side, we feel wind solar is not ready yet, but not that they cannot do it. We just need more time to figure out what is the best way to either require it, or if not, what is the reason they cannot be done.
Thanks, Fred. Sounds like ERCOT's taking a measured and kind of finger on the pulse approach as we move forward with new technologies. And I think that's great. All right, so we got a minute left here, so we'll wrap it up for the day. Thanks, Fred, so much. It was a fantastic presentation, and thanks for answering all of the questions. We'll work to get questions ready, written responses for those we didn't get to today. So as we wrap it up here, we'll thank Fred for this presentation and on the GFM activities in ERCOT this is going to be a really valuable reference and source of inspiration for all of us, right, as we're moving forward in the industry, implementing grid forming throughout as we can. As we mentioned earlier, the email we'll send out to everybody once the video has been posted. And any questions we did not get to in the Slido, we'll put together answers and get them out along with that link. We appreciate everyone's participation. And if you'd like to stay engaged, I'd like to invite you all to participate in the next ESIG webinar on November 14th on the National Transmission Planning Study, and on November 21st on IBR-driven subsynchronous oscillations. So for further information on all of the webinars and events, you can find them at the ESIG's website. That's www.esig.energy. And you can just click under events there, and you'll see all of the events from ESIG. And then for information on the G-PST webinars, you can find those at the www.globalpst.org. And then one last time, Fred, thanks again for this kind of a hot topic, timely topic. And thanks for all of the interest that you showed and participated with us at ESIG. We look forward to seeing and hearing from you again in the future. In the meantime, everybody else, please take care, stay safe, and thanks for participating today. See you all soon.
My pleasure. Thank you.
Thanks, Fred.